welcome to Heidelberg, Philip. As far as I know, this is your first time.
It is.
At Troopers. And we had, usually in the D&M track, as we say, there have been talks on device guard in the past. But I would say this is the most technical one on how to say circumvent. Maybe not attack, but not so much like from a defense perspective, but look at device guard from an offense perspective. And stage is yours, Philip.
Thank you. So, is this working? It is. So, hi, my name's Philip. I do security research for Cybereason, and sometimes I forget just how terrified I get of public speaking, which leads me to situations such as this. As Enno said, this talk is going to be about a feature called Device Guard and a couple of ways to bypass it. Some of those use VBA, some of those do not use VBA, and actually most of them are not recognized by Microsoft as actual vulnerabilities. But you know, if you have an actual attacker trying to penetrate your network, they're not going to go, oh no, the hacker code prevents me from using these bypasses. I need to find my own real 0-day and only use that. No, they're just going to use whatever is at hand. So just because these things are not vulnerabilities, it does not mean that you're not vulnerable to them. We'll see a couple of other benefits of the techniques I'm going to show because they're not only device guard bypasses, they're just other fun stuff. Well, all right then. So let's begin with a quick intro to device guard and application whitelisting altogether. So device guard is an application whitelisting that was introduced in Windows 10, and it's actually the successor of a different feature called App Locker. Now, what application whitelisting and device guard specifically tries to prevent is to have an attacker execute arbitrary code on a machine that's already compromised. It does so by basically taking a user admin specified policy that could contain stuff like certificates or hashes, names, etc., and saying, well, if it's not compliant with this policy, this code won't run. And this gives us a pretty permissive and pretty interesting threat model because the types of things you could abuse to circumvent device guard are pretty much anything you will natively have on a machine because you're basically already able to execute commands. You're just not able to execute arbitrary code. So to better define what is a device guard bypass, we'll give a bit more formal definition of arbitrary code, which at least in this case will be the ability to interact with the OS freely, meaning that you could try to ask the OS anything, and your only problem is going to be privilege. You may receive the answer that, well, you're not allowed to do this API call, or this API call will fail, but still you will be able to try. And the most direct way to do this is just having your own process and running in the context of whatever you want. And you gain this by being able to allocate code and jump to it, or by being able to execute arbitrary Windows API calls or sys calls. And of course, it's really easy to jump between those two. So you might notice that, well, this looks like everything RC tries to do, but I won't speak of buffer overflows or anything like that because, well, technically, if you can't execute code, so it's a device guard bypass, but you know, it's a bit out of scope here. So we'll try to find a bit more, let's say, logical flavored bypasses. Now, without application whitelisting, arbitrary commands simply equal arbitrary code. So there's no need for this formal definition or whatever, because, well, you could run an arbitrary command. So the way to run arbitrary code from this is like launch malware.exe, and and this file contains your code, and that's it. You have the ability to do whatever you like. But the moment application whitelisting goes into place, you suddenly have to rely on only what's permitted by the policy. And while there is this whole lolbin trend going on, you can't really implement things like Mimikatz using only native executables. Same thing with command and control. And let's say that even if you have like this really cool privilege escalation vulnerability, you simply can't run it because it will still require your own code. So this will seriously hinder an attacker, because if you have like a code execution vulnerability and you're able to run a process and you're popping calculators left and right on your test machine, and you just could reach your target machine and find out that, well, I can pop a calculator, but this won't help me on my target. So now we understand why device guard is extremely annoying from an attacker's perspective, because, well, you could circumvent and do a bit of malicious activity under device guard, but it's still not what you want. And if it's not enough, let's say you have gained the control of a single process. It's really easy to cross a couple of boundaries and again be sort of diminished into arbitrary command execution, which we have determined just sucks. So for example, if you want to persist on the system, almost every persistence mechanism in Windows lets you run an arbitrary command. Congratulations on calculator. Same thing with privilege escalations and sandbox escapes. Many of them allow you to just run an arbitrary command. So calculator is system or a calculator outside of your sandbox, which is, again, not satisfactory. And the same thing goes with lateral movement. So even if you have somehow gain control of a single process, you really need some kind of reliable device guard bypass to be able to always run your code, no matter in which context you are in. Now, device guard actually tries to protect a couple of different containers of code. The first and most direct one is B files. Basically, these are the blobs of machine code that you load. So if somebody can load an arbitrary blob of machine code, well, they have an arbitrary code execution vulnerability, in device guard at least. So if it's not whitelisted, it won't execute. It's pretty straightforward. But there are a bit subtler ways device guard protects against arbitrary execution, and these find themselves in PowerShell and ActiveScript engines. In PowerShell, you could actually execute a non-signed, unpermitted script. But this will execute in what's called constrained language mode, which allows only very specific restricted types in non-whitelisted scripts, meaning that your whole 2-day PowerShell course becomes a bit useless when you can't use any of the tricks you've been taught. So you need to somehow circumvent this to be able to, again, do whatever you want on the machine. Same thing happens with ActiveScript engines, which are the engines that implement JScript and VBScript, etc. These communicate with the operating system pretty much only through COM objects. And when you run a non-permitted ActiveScript script, you basically only get a very restricted set of COM objects. So you can't use stuff like wscript.shell or today, like the latest trendy way to achieve full arbitrary execution using ActiveScript, which is .NET to JScript. You're restricted to stuff like scripting dictionary. So you could, enter strings into a hash table, which will immensely help you in your red team operation. Now, this is a bit of a visual example of device guard. I'm trying to run unsigned.exe. Instead of execution, I'm just having this pretty blue pop-up with a really neat copy to clipboard feature, which is a really nice addition into Windows 10. Yeah. So, device guard actually tries to be user agnostic. This means that unlike the older app locker, if you have device guard on, it's on for everybody, and it's pretty much the same for everybody. But administrators could disable device guard. And yet, this requires a restart. This throws a pretty nasty event log. So if you've taken the effort to implement device guard in your environment, you should see like device guard going off as a pretty strong signal that something went wrong. So if you're not doing this, this is a huge mistake. If you are doing this, you basically, and this is the only way to bypass device guard as an admin, you basically force an attacker into asking themselves, well, do I want to forsake like real arbitrary execution, or do I want to get caught? And none of these is good. This is why some of the things I'm going to show here are actually going to require administrative credentials. but they will be able to bypass device guard without actually turning it off. And those non-vulnerability admin-style techniques are sometimes what makes the difference between an adversary staying in your network for a couple of hours and an adversary staying in your network for a couple of years. So the more of these you have, the more you have to monitor for lots of different techniques, and you, again, gain alert fatigue. And you don't have this really good baseline which allows you to say, oh, here's an anomaly, and I know this is bad. You just have lots of different behaviors. All right, so let's look at a couple of actual bypasses. The first will be VBA. Now, VBA is basically Visual Basic for Applications, or the engine that powers Office macros. And it's simply not instrumented by device guard, meaning that if you run VBA, you can run whatever VBA you'd like. And this allows you to run arbitrary WinAPI functions and run shellcode, arbitrary execution, or use arbitrary COM objects, and do stuff like .NET to JScript. And again, arbitrary execution. And well, Microsoft has told me that because it's not an integral part of Windows, it won't be instrumented with, and device guard will not be implemented, at least soon, for this. But you know, Office is pretty ubiquitous, so unless you want to say, well, this is a feature for servers only, you are going to have Office on your device-guarded machines, and this will give you pretty much tons of holes in your defense. Now, running an Office macro the naive way is pretty lame. Like, I'm going on easy mode, I'm not doing lots of real vulnerabilities, but this is too much. Like, you have to actually click the enable content stuff, and well, no, that's too lame. So even if you RDP to a machine, still, it's a bit too much. So could we actually run macros from a post-exploitation scenario without going through this whole protected mode stuff? And well, I'm speaking about this, so probably yes. And one approach is using lateral movement. So while you can't really reach those very easily from a local machine, you could actually use the Office applications COM objects and make them execute your own macros. And you can actually also use this filelessly, but this still requires admin, which is the biggest shortcoming of this technique. But I have seen environments that have enabled DCOM access to Office applications to regular users. So first of all, don't do that. Second, don't do that, actually. That's it. All right, so the way you do this is basically create a remote instance of, let's say, the Excel application COM object. You could use pretty much any other Office application. You save your macro as a string, and you do a bit of WMI magic to change the registry at the remote machine to change a small key called access VBOM that basically lets you inject macros into memory. So you could also use this with an actual file, but I don't like files, so if I can avoid them, I do. And after you do that, you simply open an empty workbook. You can also have it absolutely anonymous. You add your macro from a string. You just execute the macro runs, nobody asks any questions, and that's about it. And if you don't save the workbook, you don't even drop a file to the machine, which is pretty nice, but it would be better if we could do this locally and unprivileged. So let's try to find something with these requirements. And to do this, we need to know, when does Office just not use protected mode locally? And we don't want to change all of the macro settings because, again, if you suddenly see that all of the security settings on one machine just go down, this is really bad, unless it's a security researcher's machine, and then just use a VM, please. But there are two main ways to do so without turning down everything. And one is, well, if you've ever clicked on enable content on a macro, you know that next time you open this document, it will simply run the macro automatically. And this is because these documents become trusted, and they're saved in the registry, and there's like a bit of encoded information about the identity of the document that says, well, this is trusted, just open it and that's it. But it's encoded, and I was a bit lazy, so I found another way. And the other way is actually trusted locations. So there are trusted locations for each Office application from which documents will simply run without opening in protected mode. Because, you know, trusted is it's in the name, so you must open it and trust it. And the so-called defense against this is that the default ones are writable only by admins. So here we have, for example, ACCWiz, which is the Microsoft Access default trusted directory. And well, I can't write and I cannot write to it as an unprivileged user. So, well, fine. I still have this requirement that I don't want to use a privileged user for this. So let's look at how these things are actually represented in the registry. So we have Office 16 access security trusted locations and the very descriptive location 2. And we have like a path of the directory itself and a description, and well, that's all fine. But in a post-exploitation scenario, you could see a small problem here, and it is this. So who even cares who can write to a trusted location if you can just add your own trusted location as your own user? Because you can always write to your own HKCU. Meaning that I don't care about this ACCWiz thing. What I'm going to do is just modify the registry. I can do this pretty much directly in PowerShell in constrained language mode, because constrained language mode in PowerShell will allow you to use WMI, which I think is a bit of a problem in itself, but that's another thing to talk about. So the moment we add, let's say, ctemp as a trusted directory, we're again in a post-exploitation scenario, so we could just run any command. And all we need to do later is to run Microsoft Access.exe with our malicious access database or, I don't know, Excel sheet, Word document, or whatever, and probably supply this embedding flag that doesn't pop up a very suspicious GUI, because do you ever experience just having Microsoft Access just pull up on your screen without any notice? This does look suspicious, so you could just use it without a GUI, and then you have Notepad, because even if I'm joking about, oh yeah, the attackers can only use Notepad, etc., I'm going to use arbitrary code to launch Notepad, because you're only allowed to launch Notepad or Calc in demos. Right then, so now we understand that VBA is crap. And if you've taken the effort to actually implement this thing, which is pretty hard to do, and you have like this really modern environment, maybe you should not use Office macros, because please don't, please. So let's try to find some non-VBA based bypasses. So let's look at a couple of these. Well, we stopped using VBA macros, so the next thing we're going to use is more macros, but just worse. So Excel has another macro system, another macro feature that was introduced in '92 called XL4 macros, or XLM macros. And this is implemented in Excel.exe itself. And it actually gives you a couple of primitives for arbitrary execution, because the call and register functions allow you to basically take a name of a library, a name of a function, some really gross way to represent the arguments of the function, and then just call it. So it's disgusting, but it works. But at first, I was not able to actually use it for arbitrary execution, because I was able to like run a process, which, well, I can run a PE file. I can't run my PE file because, again, device guard. I could run a COM scriptlet, which runs JavaScript, which is instrumented by device guard, so I can do anything. And Stan and Peter from Outflank just recently had this really, really great DerbyCon talk, and they showed that you could actually run x86 shellcode, which is exactly what I needed for this. So you can actually do this via XL4 macros. And you can't really do this with 64-bit stuff, because the maximum size of the argument is is 32 bits, so I just can't cram a pointer in it. But as of today, most Office installations are still 32 bits, so this will work almost anywhere. And this looks like this. What we do is simply register, let's say, the usual suspects of shellcode, like write process memory, virtual alloc, and create thread. We actually push our shellcode as a byte array into a bit of into a cell, which is this weird value thing in the first row, because Excel actually knows how to store long byte arrays in a single cell, and then it doesn't know how to represent them. So we get an error, but the macro does not get an error, and we don't really care about how it looks. And again, we have this enable content thing, but we already know how to do macros without protected mode in a post-exploitation scenario. So first, we have the ability to do so through DCOM, again, remotely. And you connect to the Excel.application DCOM object on your target machine. You open the workbook that you've sent beforehand, this time using a file. You could actually also use a COM method called execute Excel for macro that just takes a macro from a string and executes it, because of course you have to have this. And then you do run auto macros, and it runs the whole shellcode thing, and again, launches a calculator. So this is it for macros. Now the trusted directory trick works exactly the same. You trusted directory, push your file into the trusted directory, run it, and it runs without any problem. It's the same demo, so I'm not even going to show the screenshot. And the benefit of this is that these macros are actually implemented in Excel.exe, meaning that you can't really take your policy and say, well, I'm not going to allow this DLL, this part of the code, to execute to load, because if you're using Excel, you have already loaded the macro functionality. And it doesn't really matter how hard you tinker with the settings. Most of them are in HKCU, meaning that an attacker would pretty much always be able to just change it back and execute anyway. So if you have Excel on your device-guarded machine, you could disable VBA. You could actually specifically blacklist VB7.dll, and still these macros will work. So if you have Excel, you have pretty much a device guard forever day, unless somebody decides to fix that. Because I'm not sure, did anybody use an Excel for macro for good in recent years?
For offensive purposes, of course.
Yeah. So let's move to another category called ActiveScript bypasses. This will basically abuse ActiveScript technology, which is a generic Windows scripting technology or specification. And it's what's behind VBScript and JScript. And it has already been a target of a couple of recent bypasses, such as the squibbly whatever stuff. There's a whole category of squibbly something by device guard and app locker bypasses. And what ActiveScript actually does is allows you to implement different scripting languages and then use any such implementation inside of a lot of different scripting hosts. And it looks pretty much like this. You have two main components. One is the scripting engine, which is the actual implementation of a scripting language. And the other is the scripting host, which actually does the behind-the-scenes magic that suddenly allows VBScript inside Internet Explorer to know whatever the hell HTML in the DOM is. Because if you run VBScript in, let's say, WScript, no idea what HTML is. Suddenly, you put it into Internet Explorer, and yes, of course, tags, yeah, sure. And it does so by simply exposing a lot of methods and objects to the scripting engine itself. So we have these two main parts, and there's a couple of instances of those components that are natively already present in every Windows installation. This is not a full list, but in terms of hosts, you have stuff like W and C script. You have strobj.dll, which actually implements COM scriptlets. You have stuff like MSXML3 and 6.dll that do some XML transform stuff, and you have MSHTML.dll that implements basically the Internet Explorer HTML engine. And in terms of engines, you have JScript, which is a JavaScript implementation. You have VBScript, and you have JScript9, which is another JavaScript implementation because one is not enough. And what the ActiveScript specification actually allows you is that you could run every single scripting engine under any scripting host, meaning that each of those could run both JScript, VBScript, etc. And if I, for example, want to implement a version of Python for this, which actually exists, it will also be able to run in WScripts, strobj, and even under MSHTML.dll. So I'm pretty sure you could run Python in Internet Explorer if you really try, which sounds terrible. So the way DeviceGuard is implemented in ActiveScript, as I've said before, is by using COM object filtering. Meaning that I can't get any COM object that I want. I can get like one of a very small hard-coded list. So let's say that I write a script that wants to create WScript.shell or infamous CMD running object. And what the scripting engine does in an internal function is call class ID from prog_id to turn this friendly name into the COM class's GUID. What it does later is send this GUID to a method in the host called isClassAllowed. And this one checks against hard-coded list in WLDP.dll, which is actually the user mode implementation of DeviceGuard. And if it returns that, well, that's not in my list, class creation simply fails, and the script fails. If it's in your list, you simply call co-create instance, and you have your script up and running with any object that you want. Now, of course, this only happens when you have an unsigned script. If your script is signed, it's permitted. It just runs in full mode, and nobody stops you from running WScript.shell. Now, what happens when you don't have this isClassAllowed function is that it falls back on simply, well, let's create it anyway, who cares? So the simplest way to bypass this is to find a host that does not have this isClassAllowed function implemented, meaning this host is not enlightened by DeviceGuard. So one such host is the ActiveScript event consumer, which you might know from the most common WMI persistence method, and it's implemented in strconst.exe. Now, it does not use any of the other executables or DLLs that I've mentioned in the previous list as a scripting host. It implements its own host. And this one is not supported by DeviceGuard. So while it's only available as admin, which is, of course, always worse than being available just for everybody, it's still not instrumented. And you could use it as admin pretty simply. This is the simplest implementation of WMI persistence, and you don't need to change anything at all to make it a DeviceGuard bypass. What you do is simply write your script text into the script text variable property of the ActiveScript event consumer object. You create a trigger that's basically a WMI query that says, well, here it says every time Notepad runs, do something. So we're gonna run CMD every time Notepad runs. And then we bind those two things. So every time our trigger filter, our event filter is triggered, our script is gonna run. Again, we have a scripting host that's not instrumented by DeviceGuard, so our code is gonna run uninterrupted. Another such host is the one that implements XSLT transforms. Now, these are basically files that allow you to transform an XML from one format to the other. And these support embedded scripting, meaning that you could basically write inline JScript or VBScript or whatever, and it will execute when the transform is actually being used. So again, this is implemented in MSXML 6 or 3.dll, and if you're able to use an XSL transform, it will go through MSXML, which is not instrumented by DeviceGuard, meaning that applying an arbitrary XSL to whatever XML you want will result in running your arbitrary code because you will be able to create any COM object. Now, one way to do this is, again, going back to Office, using the access transform XML method. The access COM object has this nice transform XML method that just takes a URI of a transform, of an XSL transform, a URI of an XML file, a very nice option of, do you want to run scripts? Yes, I do want to run scripts. And that's it. So you just create your access application object, create a database, and use transform XML with your XSL style sheet. And you don't really need an actual XML file. You just need to give it something. So I gave the same style sheet. And because this whole thing is going to fail XML-wise, it won't fail code execution-wise. So I'm giving it, so I'm telling you, oh yeah, sure, save this to this path does not exist.xml. And it won't get saved anyway, so you don't get any artifacts on the disk. So this is one way to use XSLT transforms. Another way is actually a modification of lateral movement method by Matt Nelson of SpectreOps, is to use Outlook, which allows you to create pretty much any COM object you like. There are some limitations. And the original method actually only worked on 32 bits and used an object that was instrumented by device guard. So you could try to use it to run a script, but it will be stopped because your script will not be signed and the COM objects are going to be filtered. But instead of that object, we could use, again, XSL templates. And these work almost the same. You just need to do 2 different COM objects instead of 1. And again, you pretty much apply the XSL template to itself or to anything, call transform, and that's it. Your arbitrary code is running. All right. So when I first showed you this thing, this was a bit of a lie by omission, because we do understand how a script gets compiled and runs in its own environment. We do understand that the host calls wldp.dll from some kind of import, but we don't exactly understand how the engine communicates with the host and asks it, hey, is this allowed? And the answer is there is no single implementation, and there are a couple of different ones, and this actually led to a type of vulnerability. So here we have 2 call stacks that show 2 different implementations. Now you could actually look at the disassembly, but it's actually easier to just look at the call stacks and understand why the vulnerability happens. So in the upper image, we have jscript9.dll running under the MS-HTML engine as a scripting host. And we see that the script engine calls a function called canObjectRun and relinquishes execution to MS-HTML. Which runs a function called hostQueryCustomPolicy, which does a couple of different checks on a COM object. And it subsequently, after another call, calls our isClassAllowed method, which is not exactly the case with the bottom picture. Here we have jscript.dll running under cscript. And we see that we have this function called getObjectFromProgID. And it directly calls isClassAllowed on cscript. So this means we have 2 different approaches. MS-HTML says, well, I'm responsible for device guard. I'm going to call isClassAllowed each time somebody's going to ask something about COM object safety. So this is my responsibility. While cscript, what it does is says, well, here's a pointer to isClassAllowed. You're a bunch of adults. You could just use this pointer whenever you want to verify a class is allowed, and basically throws the responsibility on the scripting engine. Now, both of these approaches work because, you know, the function gets called eventually and everything is fine, as long as the scripting engine developers know of both approaches. And this is not the case with JScript9. It was actually only meant to run under MS-HTML because it's basically the latest Internet Explorer engine. So the developers of JScript9 made an assumption that the scripting host is responsible for calling isClassAllowed. meaning that JScript9 never calls it by itself. Now, we can make it run using a pretty simple trick under, let's say, CScript. So now we have two different components. JScript9 says, well, I rely on my host to run isClassAllowed, and MSHTML CScript says, well, I rely on the scripting engine to run isClassAllowed. So nobody runs isClassAllowed at all, meaning that it's never called, nothing is verified, and object creation is just goes on as usual, no checks whatsoever, and we're bypassing device guard. So here we have me trying to run CScript with a JavaScript file that tries to run calculator just the normal way, and we have this automation server can't create object error. Now this is expected behavior because that's what device guard does. We can't create wscript.shell, we can't create, and we can't use it to run calculator. But CScript and wscript actually have this very nice parameter /e that receives the name, the friendly name, the prog ID of a COM object, or the GUID as a string of a COM object, and says, I'm going to use this as my scripting engine. So we could simply give it the JScript9.dll scripting engine GUID as the E parameter, and this will force CScript to use JScript and triggering our vulnerability. So isClassAllowed is never called anywhere, and we can run whatever. Now, of course, I'm running calculator. You could use .NET to JScript, and this is absolutely unprivileged, and it worked anywhere until November. Now, we could actually do the same thing about using scriptlets, because strobj.dll, the Windows scriptlet host, actually works exactly the same as CScript, meaning that it relinquishes responsibility for calling isClassAllowed to the scripting engine. And that means that if you're able to load JScript9 into strobj.dll as a host, you can again circumvent all of the device guard checks. The only additional thing that you need to do is actually register a prog ID, a friendly name for JScript9, because strobj.dll does not know how to use GUIDs. So all you need to do is write your own scriptlet, say the language is not JScript but also JScript, and then register also JScript as a real COM object to point to our class ID GUID of JScript9. And then you could run regsvr using the now pretty well-known execution method, and this time it will circumvent device guard. And I'm doing this locally, but you could do this from like a URL or something, so you could make it fileless. This is basically the one vulnerability, the one real vulnerability that got a CV that was closed in November. But there's actually a more systemic problem with device guard that allows me today to pretty much ignore most patches for device guard bypasses, but I am, as of today, still in contact with Microsoft, and I'm not really going to drop a 0-day today, so sorry about that. But I really hope that I could update my slides a couple of months from now and change this redacted to something a bit more meaningful. It's actually pretty technologically boring, even if it's very impactful, so sorry for the redacted stuff. So this is pretty much it for the bypasses themselves. But, well, what if you don't use device guard like pretty much everybody? What can you gain from these weird techniques that I've just shown? So first of all, this is a couple of less known and I think most of them unpublished new execution techniques. And it's always good to know that you can execute things in a way that defenders, blue teams don't recognize. So we have a couple of new lateral movement methods. Some of them are fileless, which is always nice. And actually, the JScript9 exploit is also an AMSI bypass, and this was not and probably will not get fixed because earlier today I had a talk with Carlos Perez, and he said he was teaching this AMSI bypass for a couple of years in his PowerShell course, And he told Microsoft about it quite a while ago, so this is not going away. So if you want to use WScript or CScript or whatever, and you're afraid of AMSI, just use the JScript9 trick and no AMSI for you. And that's it. And I thought about it and found out you could use a very similar trick to, again, bypass AMSI. Because it's not enough that there are two ActiveScript JavaScript implementations. There are natively 3 ActiveScript-based JS implementations. Now, chakra.dll is another library less related to the other two. And it actually has no ActiveX functionality of itself, meaning that, well, fine, I don't have AMSI, but I also don't have COM objects, so I can't really interact with the machine itself. But if it's run under WScript or CScript as the scripting host, it actually provides an object and a method that allows you to create arbitrary COM objects of your own. So instead of using new ActiveX object, you just use WScript.createObject, which is a function provided by the host, and create objects anyway. Now, this is not another device guard vulnerability, because the developers of C and WScript actually wired WScript.createObject to the isClassAllowed function. So if you try to use this under device guard, it won't work. But if you try to use this just on a normal machine, this will be another pretty obscure AMSI bypass, which is also nice. And you can do some neat tricks like taking JScript or chakra.dll, not making it do anything malicious by itself, but actually use it to drive Excel using Excel for macros. So you have an instance of Excel without any file, pretty much executing arbitrary WinAPI commands without any injections, without anything, and you have an instance of WScript not really interacting with the operating system that much. And I don't know, have you ever seen like a single instance of Excel not loading any file, not getting injected or anything, and thought, oh wow, this is super suspicious? I think there are things that are a bit more suspicious than that. So now let's move on to a quick conclusion. So first of all, I've shown a couple of pretty different techniques, but actually, if you're monitoring your network even for a bit, you probably have most of the optics that you need to detect all of these techniques, because almost everything could be detected using command line or loaded DLLs, or maybe a tiny bit of registry monitoring. You don't need to find some kind of obscure way to view what's going on. So all you need to do is to actually recognize these types of attacks, and you probably only need to implement detection logic and not new collection mechanisms. I have a couple of thoughts about how the features should develop, and the first is please lock down Office, because again, if we don't want device guard to be a server feature, we really need to look at like the most ubiquitous Microsoft-made software package and maybe lock it down too. Also, I'm not exactly sure I've abused the only bug that stems for those inconsistent device guard implementations. And even now, this patch, it stops this vulnerability, but it doesn't really make a consistent implementation. So we still have a couple of differences which could be abused, and this is probably what I'm going to do when I go home. And also, well, let's say you want to use Java on your machine. Well, that's it. Device guard is broken because it's not a PE file, it's not a script, and it's not PowerShell. So it would be really nice to have like some kind of API or toolkit to be able to give to software vendors, especially like scripting interpreter and JITted language vendors, to say, well, here's how you can implement application whitelisting on top of device guard, so I won't be afraid to use Java on a device guarded environment. And this is pretty much it for my talk. Because of time constraints, I couldn't really reference all of the previous work because there's tons. But if you're interested in device guard itself, these are pretty much the people that you should follow. Each of them has a couple of very interesting device guard bypasses and explanations about how device guard is implemented. So follow these guys. Anyway, this was my talk, so any questions?